Welcome to this presentation on the future of sustainable wearable electronics. As wearable technology continues growing, however, concerns about electronic waste, resource consumption, and environmental sustainability are becoming more important. This presentation explores how the wearable electronics industry is evolving toward more sustainable solutions through eco-friendly materials, repairable designs, renewable energy systems, and improved recycling practices. Wearable electronics have experienced tremendous growth over the past decade. Smartwatches and fitness trackers have become essential tools for communication, health monitoring, exercise tracking, navigation, and productivity. Consumers are increasingly drawn to devices that provide real-time data and seamless integration with smartphones and digital ecosystems. Wearables now play important roles in healthcare, fitness, business operations, and personal convenience. As demand continues rising, manufacturers release new products with advanced sensors, improved connectivity, and more powerful features. While these innovations improve functionality and user experience, they also contribute to growing environmental concerns associated with manufacturing and disposal. Many wearable devices are currently designed with short lifespans and limited repairability. Sealed casings, non-replaceable batteries, and rapid upgrade cycles often encourage consumers to replace products frequently instead of repairing them. Although wearables are compact, they contain plastics, lithium-based batteries, circuit boards, rare earth metals, and other materials that require significant energy and resource extraction during manufacturing. As millions of wearable devices are sold every year, the environmental impact of producing, replacing, and disposing of these products continues increasing. Without more sustainable systems, wearable electronics may become an even larger contributor to global electronic waste in the future. One of the most promising developments in sustainable wearable electronics is the use of eco-friendly materials. Researchers and manufacturers are exploring alternatives to traditional plastics and resource-intensive manufacturing components. Bioplastics derived from natural materials such as cornstarch and algae may help reduce environmental impact while improving recyclability. Some companies are also experimenting with recycled ocean plastics, reclaimed metals, and vegan leather materials for wearable straps and casings. Using recyclable and biodegradable materials can reduce carbon emissions, lower dependence on virgin resources, and simplify end-of-life recycling processes. Sustainable material innovation is becoming a major focus within the future of wearable technology. Another important shift in the wearable industry is the move toward modular and repairable product design. Modular devices allow individual components such as batteries, sensors, or bands to be replaced without discarding the entire product. Repairable designs help extend product lifespan and reduce electronic waste generation. Consumers are more likely to continue using devices when repairs are practical, affordable, and accessible. Manufacturers are also beginning to recognize the importance of longer software support. Continued operating system updates help older devices remain functional and secure for longer periods, reducing unnecessary replacement cycles. Battery sustainability remains one of the biggest environmental challenges for wearable electronics. Most current devices rely on lithium-based batteries, which require mining and resource-intensive manufacturing processes. Researchers are now developing energy harvesting systems that may eventually reduce or eliminate the need for conventional charging methods. Technologies such as solar charging, kinetic energy systems, and thermoelectric generators can convert movement or body heat into electricity. Future wearable devices may be capable of charging themselves during normal use. These innovations could significantly reduce battery waste, improve energy efficiency, and lower the environmental impact of wearable electronics over time. Many companies are beginning to embrace circular economy principles and closed-loop recycling systems for wearable electronics. In these systems, old devices are collected, recycled, refurbished, or reused instead of discarded. Take-back programs encourage consumers to return outdated electronics for proper recycling and material recovery. Valuable resources such as metals and plastics can then be reused in the manufacturing of new products. Closed-loop systems help reduce waste generation conserve natural resources, and decrease the environmental impact associated with mining and manufacturing new materials. Circular economies are becoming increasingly important for the future of sustainable electronics. Researchers are also developing advanced smart materials that are safer for both users and the environment. Biocompatible materials are designed for long-term contact with the human body without causing irritation or health concerns. Some experimental wearable devices are even being developed using biodegradable materials that naturally break down after use. These technologies may be especially useful for temporary medical wearables and disposable health monitoring systems. Improved materials not only support user comfort and safety, but also simplify disposal and recycling processes. Sustainable material innovation has the potential to dramatically reduce future wearable e-waste. Consumers are becoming increasingly aware of the environmental impact associated with electronics manufacturing and disposal. Many buyers now consider sustainability when choosing wearable devices and technology brands. Companies that prioritize ethical sourcing, repairability, recycling programs, and eco-friendly materials may gain stronger customer trust and loyalty. Sustainability is quickly becoming an important competitive advantage within the electronics market. Public demand for longer-lasting and environmentally responsible products can encourage manufacturers to improve design practices and invest in cleaner technologies. Consumer behavior plays a major role in shaping the future of sustainable wearable electronics. Governments and industry leaders both play important roles in advancing sustainable electronic systems. Environmental regulations can encourage manufacturers to prioritize repairability, recyclability, and safer material usage. Public investment in recycling infrastructure and research programs can help improve waste management systems for wearable electronics. Industry collaboration can also establish shared sustainability standards and improve product accountability. Policies such as right-to-repair legislation and extended producer responsibility programs may further encourage manufacturers to design products that are easier to repair, recycle, and maintain over longer periods. Despite significant progress, creating fully sustainable wearable electronics still presents major challenges. Manufacturers must balance consumer expectations for performance, style, affordability, and compact design with environmental responsibility. Sustainable materials and modular systems may increase production costs or require design compromises that companies must carefully manage. In addition, recycling infrastructure for wearable devices remains limited in many areas. Long-term progress will require continued innovation, public awareness, industry cooperation, and investment in cleaner technologies. Sustainability must become a long-term priority throughout the electronics industry. The future of wearable technology will likely focus not only on smarter features, but also on smarter sustainability practices. Eco-friendly materials, renewable energy systems, repairable designs, and responsible recycling are shaping the next generation of wearable electronics. Manufacturers, recyclers, governments, and consumers all share responsibility for reducing the environmental impact of wearable technology. Licensed recyclers will continue playing an important role in helping safely recover valuable materials from discarded electronics. By combining innovation with sustainability, the wearable electronics industry can continue improving lives while also protecting the environment and conserving resources for future generations. Thank you for taking the time to learn more about the future of sustainable wearable electronics and the importance of environmentally responsible innovation. As wearable technology continues expanding worldwide, sustainable product design, cleaner energy systems, and responsible recycling practices will be essential for reducing electronic waste and protecting environmental health. Reach us by phone, email, or our website. The future of wearable technology depends on creating smarter devices that support both innovation and environmental sustainability.